This is Orekoya from the Olusegun for the Mathematics Physics Fundamental Tutor. You can visit me on my website. Thank you. Today we are taking the application of differential calculus. From each of the four corners of a rectangular sheet of metal 50 cm by 80 cm, a square of side r cm is removed. The remainder is then formed into a cuboid in shape. Find the value of r for which the volume contained is maximum. Now, for instance, the original metallic sheet here is rectangular. The length is 80 cm and the breadth is 50 cm. When we cut out square of side r on all the corner of the rectangular metal sheet, we discover that the length will be 80 take away 2r and the breadth is 50 take away 2r. Now, when we now use this particular sheet of metal to form a cuboid, we have the length of the cuboid to be 80 take away 2r and the breadth 50 take away 2r and the height is r. And the volume of this particular cuboid is base area times height, and the base is length by breadth, the height is h. Therefore, the volume is 80 minus 2r bracket 50 minus 2r bracket r. Now, when we open the bracket, we have volume to be this. Now, but at maximum value, the rate of change of volume related to the length r is 0, and the second derivative of the rate of change of volume related to the length is 0. Now, the rate of change of the volume related to r, this particular r, using the first principle of differentiation, we discover that 3 times 4 we have 12, 2 times 260 we have 520, and then 1 times 400 we have 400. Everything equal to 0. Divided through by 4, we have divided r to be 3r squared minus 130r plus 1000. Now, we can recognize this arrangement as a quadratic equation. Factorizing the quadratic equation, we discover that we have the equation turned into 3r squared minus r minus 30r plus 130 plus 1000. Factorizing r out, we discover that we have this arrangement. When we take away r from here and when we factorize minus 10r, we have this particular arrangement. Now, making r the subject of formula, our r is 10 or r is 1 over 100 divided by 3. But one of these two, we make this particular cuboid to be maximum. Now, at maximum, the second derivative of the volume with respect to the length must be less than 0. That must be negative. When we substitute 10 here for the second derivative, we discover that our answer is minus 7, which is less than what? 0. Therefore, when the length r is 10, that means the length of the cut out square, when it is 10, then we can be able to form a maximum volume of this cuboid. So, if you test the second value of r, we discover that our results will be greater than 0. That is talking about minimum. That's why we are selecting r to be 10 cm. Now, you have to know something. As turning point, any of the turning point of any function y of x, the y the x is 0. And we have 3 categories of turning points. We talk about a minimum point, we talk about a maximum point, and we talk about a point called the point of inflection. A point of inflection is a point which is neither minimum nor maximum. Now, when we make reference to minimum point, our second derivative of y related to x was greater than 0. When we make reference to the maximum point, our second derivative of y related to x was greater than 0. Now, if our second derivative of y related to x, second derivative is equal to 0, then we have what is called the point of inflection. Thank you so much. You are all welcome.